All right, today we're going to architect a modern data pipeline on Google Cloud. We're talking powerful, super scalable, and best of all, completely serverless. Let's dive right in.
So let's start with the fundamental question we're trying to solve here. Imagine this endless stream of files just showing up. Logs, user events, data from IoT sensors. How on earth do you build a system that can just handle all of that automatically, without a single server to patch or provision or ever have to worry about?
The old way was such a headache. We had to guess our capacity, which meant we were always paying for machines just sitting there doing nothing. And then when traffic spiked, it was a scramble. The serverless way, though, it's a completely different mindset. It's reactive. You only pay for the exact compute you use, and the system can scale from 0 to absolutely massive and then right back down to 0, all by itself.
To make this all feel a bit more real, we're not just going to talk about abstract services. No, we're going to follow the journey of one single piece of data. We're going to watch it from the moment it's born as just a raw file, see how it kicks off this amazing chain reaction, and follow it all the way until it becomes a valuable, queryable insight.
And this right here, this is our map for that journey. Every single data pipeline, doesn't matter how simple or complex, follows these 4 basic stages. We're going to walk through each one and see exactly how all the serverless pieces on Google Cloud fit together like a puzzle.
So, our data's journey kicks off right here. These first 2 steps, ingest and trigger, are all about one thing: getting the data into our system and starting the whole workflow without anyone having to lift a finger.
Okay, so the whole thing starts the moment a file gets uploaded to a Google Cloud storage bucket. It could be anything: a CSV, a JSON file, an image, you name it. Just think of cloud storage as the universal loading dock for your entire cloud setup. It's super simple, incredibly durable, and it's built for unbelievable scale.
Now, this is a really fundamental shift in thinking. In a serverless world, that file arriving isn't just data sitting there doing nothing. No, it's an event. It's like a signal flare shooting up into the sky, telling the rest of our system, hey, wake up, we've got work to do.
And who's on the lookout for that signal flare? Well, that would be these services. Cloud Functions and Cloud Run act like the pipeline's dispatchers. They're set up to just listen for specific events, like, say, a new file being created in our storage bucket. The second they see that event, they instantly spin up, run a bit of code, and kick off the next stage of our process. Okay, so our data has been ingested and our trigger has fired. Now we come to a really critical decision point in our pipeline. We have to choose how we're actually going to process and transform this data.
And this is really the core choice, right? Do we send our data down this massive, managed superhighway that's built for heavy-duty data traffic? Or do we build our own custom little path, one that's perfectly tailored for a very specific, lightweight task? This decision is a big deal. It impacts your cost, your complexity, and your performance.
Let's break down these trade-offs. On the left, you've got data flow, our managed highway. It's absolutely perfect for those really complex, large-scale jobs where you need massive parallelism but you don't want to manage any servers. On the right, that's our custom path using Cloud Functions or Cloud Run. This gives you total control for smaller, more specific tasks. And, this is huge, it scales to absolute 0. That means if it's not running, you're paying nothing. The key here is to match the right tool for the job.
So, to put it simply, you're going to reach for data flow when you're dealing with serious data crunching. We're talking transforming terabytes of data, joining multiple data streams, or running really complex analytics. It's the industrial strength heavy lifter.
On the other hand, you'll build your own pipeline with Cloud Functions or Cloud Run for all those quick, nimble tasks. Things like resizing an image when it's uploaded, or validating a single record from a file, or maybe calling an outside API. It's perfect for that fast, focused, event-driven kind of work.
So, our data's been ingested, triggered, and processed. Now it's time for the final stage of its journey, finding a permanent, structured home where it can actually be analyzed. And then we'll zoom out and look at the blueprint that holds this whole thing together.
After all that transformation, our data finally lands in BigQuery. Now, if cloud storage was the loading dock, think of BigQuery as this huge, perfectly organized central library. It's a serverless data warehouse where our now clean, structured data is stored, ready to be queried and analyzed in seconds, no matter how much data you throw at it. The journey from raw file to queryable insight is officially complete.
But hold on, how do all these different pieces, from storage to processing to the warehouse, how do they all talk to each other reliably? Well, that's where you use services like PubSub for messaging between steps, or maybe Cloud Scheduler for running pipelines on a set schedule. They are the absolutely essential connective tissue that makes the whole workflow robust and reliable.
Okay, so we understand all the components, but how do you go from a simple proof of concept to a truly production-ready pipeline that you can bet your job on? Well, that's where this design checklist comes in.
First up, idempotency. I know, it's a bit of a mouthful, but the idea is simple. It means your process can run multiple times on the same input and still produce the exact same result. It's critical for preventing messed up data. Next, you have to plan for failure. Things will go wrong, so implement automatic retries for those temporary glitches and use what's called a dead letter queue to catch and analyze any events that just keep failing. Third, monitor everything. You can't fix what you can't see, so use logging and metrics to get a clear picture of your pipeline's health. And finally, security. This one's non-negotiable. Always use the principle of least privilege, making sure every component has only the exact permissions it needs to do its job and nothing more.
So listen, this isn't just some boring checklist you tick off. This is the blueprint. Following these principles is what takes your architecture from being a cool experiment and turns it into a reliable, scalable, and secure system that your business can actually depend on. This is the recipe for success.
And with that, we've built a fully automated serverless data pipeline. But I want to leave you with one final thought. The journey doesn't have to end here. Now that all your data is clean, structured, and easily accessible in BigQuery, the next logical step is to make it intelligent. What happens when you start layering machine learning on top of this automated flow? That, my friends, is where the real magic begins.